This is just another short video presentation for regression. This problem comes from our lab manual, page 18. It's number 5. So one of the things that you might notice is that I've taken the data that was given in the table in the lab manual and I've put it into 2 columns in the Excel spreadsheet. Because I know that I'm going to be running different types of models for this data, I wanted to come up with a years since, so I decided I would let 1980 be my marker. So instead of typing in 1985, I've typed in 5, and so on with my input values. The next thing that we're going to do is we're going to go ahead and type in our column for disposable income. If you want to pause this video at any time to be able to set yours up, feel free, and then come back and continue it with me. The next thing that we're going to do is highlight our data, insert a scatter plot, and you can see that we have just the data points that are given in the table here. We're going to right-click any of our points and we're going to add a trend line. So the default trend line is linear, and you can display the equation on the chart and display the r-squared value on the chart. Hit close. That gives you a pretty decent model. It looks like we have an r-squared value of 0.986, which is pretty good. But we want to do another. So let's go ahead, insert another scatter plot, right-click, add a trend line, but let's do something different this time. Suppose we try an exponential model. Display the equation, display the r-squared value, close. Well, you can see that if it was just between the exponential and the linear, that at that point we would pick the linear. We're looking at that r-squared value. This is not as close to 1 as the one with the linear. So let's scoot that one out of the way. And again, highlight our data, insert a scatter plot. It's really good to try as many models as you can to get an idea of the best model. So we're going to add a trend line again. So this time we've already tried exponential, we've tried linear. Let's try logarithmic. Display equation, display r-squared value. And that model, pretty similar to the one that we got for our exponential model. The logarithmic model looks to be a little bit better. Move that out of the way. Let's try another. Insert, scatter plot. This time, let's try a polynomial of order 2. That'll be a quadratic model. Okay, so now we've got at least a little bit better model. This one is the first one that we've seen that appears to be a little bit better model even than our linear model. They're very close there. Let's try one more model. And for this one, let's try a power model. Notice each time I'm clicking display the equation and display the r-squared value. Okay, and in that one we don't have a very good model at all. So it appears from just the regressions that we've run that our quadratic model and our linear model really are the best 2 models that we have. So the next thing that we might want to do is let's go ahead and type in a quadratic prediction. If I want to wrap my text. So the quadratic prediction is going to come here from this quadratic model. So we know that we're going to start with our equal sign, negative 0.00 0.49 times our x value is going to come from A2, access that, square it, minus 0.3121 times our x value again, plus 10.451. Hit enter, and let's double click that down. So with that, we can certainly see that we've got some pretty good things going on as far as if I took my residuals now and I wanted to take a look at the residuals. With the residuals, I know that that's a very simple formula. It's just going to be the actual amount minus the predicted amount. And if you look at that, all of my residuals are hovering very close to 0, which is what we want to happen there. So if we use that model, and if you wanted here, you could go and put in your linear model as well and do the same thing with it. I really just want to come back and look at the questions now and see what we're being asked to do. So one of the things that it asks us to do is use the equation to find the output in 2008. So if you look at the values here, remember this is 1985, 86. This would be 2001, would be 21. So it appears that if we wanted to find 2008, we would simply have to type in 28. It gives us a quadratic value of negative 0.1294. So what's interesting about that is using the quadratic model, it gives us a negative % of disposable income that's being saved. So that could be interpreted a couple of different ways. It says use GoalSeek to find in what year the percentage of disposable income saved will reach 0%. So let's go back up here and just let's go perhaps in the cell above it. And if we go in the cell above it, notice that we're always going to GoalSeek from a formula. And so the formula that we're goal seeking from is the formula that we typed in for our quadratic prediction. So now we're going to say data, what if, goal seek, and we're goal seeking to 0. We want to know in what year that happens. So the cell that we're going to change is the cell that's input with that particular row. That tells us that in the year, that would be what, 2004, just after the start perhaps of 2004, the amount of disposable income that's being saved will reach 0%. Now, you could go through and do the same thing with your linear model. And with your linear model, if we go back down and look at our prediction here, for our linear model, we would simply type in this prediction equal to negative 0.3978 times our input value plus 10.669. Enter. Drag it down. And again here, you can see that it's decreasing linearly. In the year 28, which would be 2008, again you get a negative value. If you wanted to, again, goal seek that one, let's add a dummy row to see what happens here. Suppose we add a dummy row of, I don't know, let's try 18. Then we would take our linear prediction, what if, goal seek 0. And because this linear line is not falling quite as fast as the quadratic model, using the linear prediction, we basically hit 0 saved in the year 2006, closer to 2007. But notice, this was where we goal seek to 0 for our quadratic prediction. Here we goal seek to 0 for our linear prediction. But the other thing with this is this 28, that's in 2008. We got negative values from both our quadratic and our linear predictions. Everyone, use Excel to your advantage when you're writing your regression equations.